Hello, welcome to section 6.1. This is all about the composition of functions, where you put one function inside of the other function. So the first thing we're going to start with is notation. G, I don't know why I said G, I said it's an F. F of G of X means the G function is inside the F function. That can be also written F with a little circle G, parentheses around that, of X. So that's one way to, that's a different way to write the same thing. Also, G with a little circle F of X would be G of F of X. Now, I prefer, and I think it's easier to understand if it's written those two ways, because you can see that right here, the F function is going inside the G function, and here the G function is going inside the F function. The fog and the Goff notation, you'll see it written different places. I think it's not as easy to understand. So I'm going to kind of go with the two things I highlighted there in red. Whoops. Example 1. Sometimes we just put numbers in. So we start from the inside out, and we're going to evaluate these. So A, here's our functions. Function notation allows me to separate. So I got an F function, which is adding 1 to X and taking the square root. I got a G function. That would be tripling a number. And then I got this rational function over here, this H function, where I'm squaring a number, adding 2 to it, and then dividing that result into 3. So the first thing it says to do is G of 4, G of 4. So I'm going to put 4 into the G function. Well, that would be 3 times 4. And then that result is going to go into the F function. 3 times 4 is 12, so now I'm doing F of 12. 12 has to go into the F function. So F function is the square root of a number plus 1, and that number is 12. So the answer is the square root of 13. It's not that dramatic of an answer. It's the square root of 13, which is an irrational number. So there it is. Let me erase here. Get the big eraser out. All right. So let's talk about that again. So what do? We took 4 and put it into, the G function, because that's what it says to do, G of 4. G of 4 is 12, so now I'm doing F of 12, put 12 into the F function, which would be 12 plus 1, that's X, square root of 13. When you put a function back into a function, that's called a recursive function. So 1 is going into the F function. So I put 1 into the F function, it would be the square root of 1 plus 1. That is going right back into the F function. Well, the square root of 1 plus 1 would be the square root of 2. So the square root of 2 is going into the F function. So this is kind of a weird answer. It would be the square root of something plus 1, and what's going in? The square root of 2. So it's a double square root situation. Then you can do 3 of these. We're going to put the 8 into the F, and then the G, and then the H. So that 8 goes into the F, I get an answer, then I go to the G, then that answer goes into the H equation. Why don't you try that for a second, pause the video, give that an old Harvard try and see what you come up with. And here's the answer. So 8 goes into the F equation, so that'd be the square root of 8 plus 1. That answer goes into the G and then the H. So now I have let's see, H of G of the square root of 9, which is 3. That's supposed to be a 9. So that would be H of G of 3. So now 3 needs to go into the G equation. Well, 3 times 3 is 9. So G of 3 is 9. So now I have to do H of 9. 9 needs to go into the H equation, and that would be squaring 9. So it'd be 3 over 9 squared plus 2, which is 3 over 83. 9 squared is 81, plus 2 more is 82. So not a real flashy answer. It's a weird fraction. So that's how you do that. So putting numbers in, right? So if you go back go back and think about this for a second, getting out the big eraser, erasing all of this. So you just work yourself from the inside out, and I'm going to pick up the highlighter tool. All right, so you need to know this answer first. That was 12, and then that answer goes into the F equation. You need to know this answer first, and then that answer goes into the F equation. And then you go from here to there, across. All right, next slide is the same three functions, but now we're putting a function inside of a function. So I can start anywhere on this that I want to. I use green on this slide here. So the whole F equation goes into the G equation. What's the G equation about? Well, the G equation about is 3 times something. So it's 3 times something. So what goes in? The whole F equation. And the whole F equation is square root x plus 1. So the whole F equation, this whole F equation went inside of the G equation. That's what we're doing. Whole F equation went inside of the G equation. All right. Ooh, erase this off of there. So how did I do this? I thought about it from the outside in. And if you go back to here, I thought about it from the inside out. But now I'm thinking about it from the outside in. So I started here and then worked my way out. Now I'm kind of thinking about this backwards. I'm going from the outside in. So I thought about 3 is the G function times something, square root x plus 1. The next one's the H function. The H function is 3 over something squared plus 2. And when the G function goes in, the G goes inside this H. That's the H function I've written there. Now I put G inside of it, which is 3x. Simplified, 3 over, well, 3 squared would be 9x squared plus 2. Now I'm putting the G into the G. Well, the G function is 3 times something, and I'm putting G in it. So I'm putting 3x inside of the 3 times function. So I get 9x. Now I'm going to do the decomposition of functions, where I take a function and split it apart. So this is all about the order of operations. The order of operations says that you would do this part first. So I'm going to call that the G function. G of x is equal to 2x plus 4. So that's my inside function, and because that's what I would do first. I would double a number and then add 4 to it. Then the last thing I would do in the order of operations is I would raise it to the third power, right? So that's the last thing I would do. So I'm going to make the F function, f of x is something, which would be x to the third power. So how is the H function built? The H function is taking the G function here and putting it inside the F function. So I would write f of g of x. And that's decomposing the two functions. So that's the deal here. I think that's my last, that's my example. Here's the assignment. I'll kind of demonstrate a couple of them to begin with here, but let's see, flipping back through here. So there's the notation. You can do this with numbers. You can put functions inside of functions, or you can split the functions up and talk about an inside function and an outside function. All right, there's the assignment. Here's number 9. So number 9 is based on a table. So A would be f of g of 1. So I don't like the fog and the Goff notation, so I'm writing it this way because this makes more sense to me. I'm putting the 1 into the g. So 1 is right here, and it's going into g. That would be 0. So now I have f of 0. Get it? So I'm reading the numbers off the table instead of an equation. And then I have to do f of 0. Okay, here's 0, and f coming out would be -1. So the answer is -1. So that's the idea with that. And you can do the rest of them off the table. Number 11 and 12 are based on a graph. So the graph and the table are basically the same thing. So on 11a, I think you had to do 11, right? Yep, 11a. Probably making you dizzy now, aren't I? 11a is g of f of -1. Again, that's how I prefer to write it. I'm putting -1 into the f equation, and then, well, there's no equation, graph, and then the g comes out. So here's the f equation. f of negative 1 is 1. It's right there. So f of negative 1 is 1 because that's the f equation. So g of negative 1, f of negative 1 is 1. Okay, now I do g of 1. So the g equation is this curvy thing up here. Go over 1 and up right there. The answer would be, the answer would be 4, right? Because over 1, up 4, it's right there. So that's how you do those. You read them off the graph. Then when you get to number 13, it's actually the numbers, and you're supposed to do all these. You're supposed to do this, 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 and this. And so on A, you're putting 4 into the g equation, get an answer, put that answer into the f equation. And then you do that for the rest of them here. So I think that pretty much summarizes. Here you're putting the equation into the equation, and then here you're supposed to do the same thing. And here we're decomposing the function. It's supposed to show how the functions are one inside of the other. All right, so that ends the video.